Can you talk the talk about basic LAN switching in an interview right now? Well, you should practice. This video helps with some initial interview questions and then some follow-up questions. Take a look. It's the big day. You sit down for a technical interview while you're interviewing for that new job, and on the marker board you see a diagram like this. And you're talking to one of the people you might work with, and they ask you these initial questions. They say, what will be in both switches' MAC address tables when they're full? And then they give you three scenarios as shown here. At which ports will the frame sent by PC11 to PC22's MAC address, at which ports will the switches forward that frame in these three scenarios? When both tables are full, or when switch 1's is full but you just emptied or cleared out switch 2's, or the reverse. You have switch 2's is full but switch 1's table has been emptied out. So they ask that, and it's just a place for them to hear what you have to say and then ask follow-up questions, which will come in just a moment. So that's the idea. As for style, what should you do here? So when you answer, you could find a quiet place and speak out loud. I encourage you to somehow do more than think. So speak out loud, speak to others if someone will listen to you, family member, colleague, whatever. Or write your answer, type it in somewhere, or even find an online forum where people can share. I give you permission to screenshot the questions and the diagram and put them out there. I just ask that you link back to the video as well to draw some things to the channel. But anyway, engage with it. Don't just think about it. That's one of the big learning points here. When you're answering, strive for accuracy. What you do say needs to be accurate, just like you would want in an interview. Use as much terminology as you can remember, and make sure the way you describe it is clear. You want to strive for clarity. All right, those are your marching orders. Hit pause now. I'll give you a few seconds to do so before I start talking about it. One last warning, spoiler alert, I'm about to start talking about the answers to your interview question. So here we go after the end of the timer. All right, so there's your drawing, and I'm just going to describe the answer rather than quote an answer as if I was being interviewed. But here's what I would be listening for if I was interviewing you. I'd want to understand what you think's in the MAC table. I would want to hear that you think ports and MAC addresses and VLANs were in the table, as you see here. We've got 4 endpoints. I'd want to hear what you thought about all 4 MAC addresses in both tables. And I'd want to know that you thought of the correct interfaces as being in the table, as are shown in those tables. So if you wrote an answer in particular, I would expect you to have had that accurate based on the diagram. So you can hit pause and check through that if you like. Now, let's consider a frame sent from PC11 to 22. In the first of those 3 cases, that's where the tables are still full. So PC22's address is this mostly D's address that's at the bottom of the table. So we can tell from the tables we're going to match an entry, and switch 1's going to forward only out gig 111 per the table, and over here on the right, switch 2 only on gig 102. So just putting a little doodad beside those 2 ports. Those are the ports I would expect the interviewee to say, hey, it's going to be forwarded out those 2 ports. And I would expect them to also say that they're not forwarded, or the frame is not forwarded out all the other ports, and why, right? For instance, it's not forwarded out gig 101 because that's the arrival port. It's not forwarded out here and here because both switches matched the MAC address table and had a matching entry that told the switch where to forward the frame next, so it didn't need to flood the frame. All right, same source and destination, but now we've cleared out switch 2's MAC table. So with switch 2's MAC table cleared, we have the same answer on switch 1 because the table's still full. But once the frame arrives in over at switch 2, the question becomes, where does it send the frame? Well, it floods it, of course, right? So it's going to flood it out all the ports except the arrival port, which is gig 112 in this case. So we put the little orange doodad beside those to signify the frame would be forwarded out those bottom 2 ports. So I'd expect the interviewee to be able to explain why we flood there. And then conversely, if we emptied out switch 1's MAC table, by the way, there is a command to do that in lab, so you can play around with this. But if switch 1's MAC table is empty, and this frame came in from PC11 and get to switch 1, who would then flood, right? So in that case, the flooding would happen out the other 2 ports on switch 1, including the one connected down to PC12. Is that okay? Yes, in fact, that might be a good additional follow-up question. Why is it okay for PC12 to get a copy of that frame? What's the deal? And that would ask you whether you knew the logic behind a host receiving the frame, seeing it's not the host's destination MAC address, and the host discarding the frame. Then over on switch 2, it uses that final MAC table entry to forward the frame out gig 102. So you answered well, and then the interviewer decides to ask you more questions about the same thing. That's very common in a technical interview. They want to go deeper and deeper to see how much you really know about the topic. So here are the next few. What about the MAC addresses on switch interfaces? Are they learned? If they are, why? If they aren't, why not? That kind of thing. So what would you answer, right? So now's the time to pause. So go ahead and hit the pause button, and I'll give you a few seconds to do so before I start talking about an answer. All right, here we go. So up at the top, we see our formerly full tables, and now I'll talk about how a couple of new entries will probably appear in this design. So here's the deal. We've got these switch interfaces spread around here, and they do indeed have MAC addresses. You can see them in the output of some show commands in the switches, show interfaces in particular. But are they learned? Well, it turns out, remember how learning works, is a frame occurs and it enters a switch. So think about that. We've got switch 1, and it's got, say, 3 MAC addresses for these 3 interfaces, but switch 1's not going to create a frame and send it to itself. But it might create a frame and send it over to switch 2. And likewise, switch 2 might create a frame and send it over to switch 1. So if I represent that idea here in the middle with this double arrow line, indeed, there are reasons why these switches, because of some overhead protocols, they create messages, they put them in Ethernet frames, and they send them out their interfaces. And the ones that end up flowing between 2 switches, the switches learn the neighboring switch's MAC address on the connected interfaces. So what gets learned here? Oh, by the way, some of those overhead protocols, spanning tree, rapid spanning tree, dynamic trunking protocol, CDP, LLDP, which we haven't talked about in sequence in this playlist yet, but there are overhead protocols, of course, working on these devices. So they send these messages and say when switch 2 sends one to switch 1, it uses the outgoing interface's MAC address as the source. So what gets learned? Well, switch 2 would use its pseudo MAC address 2 here. That ends up in switch 1's MAC table. And then likewise, if switch 1 is using pseudo MAC address 1, that ends up over here in switch 2's table. Now the actual MAC would be some 12 hex digit number. I just made it simpler to talk about there. And that's the kind of thing now that ends up in the table. Now you don't say have switch 2 learn the MAC addresses of these far away interfaces, because these overhead protocols are not generating messages that then flow in on those other interfaces. Thanks so much for staying until the end. Hope you like this interview style of review activity. Leave me some comments, let me know what you think, and if you really liked it, share it around and help us build up the viewership of the channel. Hey, thanks for hanging out. Talk to you soon.